Ladies and gentlemen, it's Diamond from the Oppenheimer Ranch Project and Magnetic Reversal News, and we're bringing you a very special podcast today. Take a look who's up there in the top right corner. That is Maverickstar Reloaded Gene Beards, and he is the head of the MavStar Obsrevatory, and he's the exclusive man with access to the TriMag data. Now, we haven't done a podcast in months, and a lot has gone on, Gene. But before that, we start getting into the science. How the heck are you?
Absolutely fantastic, Dave. As always, pleasure to be with you. And, I think some of the people are going to find this very interesting, what we've got to talk about and discuss during this podcast.
Well, Gene, these are indeed very unique and interesting times that we live in. We're living during a magnetic excursion, which could actually be a polar reversal. Nobody knows. We are descending into the next grand minima phase, which occurs every 350 to 400 years as our sun shuts down. And both of these effects, increased cosmic rays, changes in our magnetosphere, changes in weather patterns. But let's get to the MavStar Reloaded channel, which for those of you listening for the first time, this is Gene's channel over on YouTube. So if you're new, come and subscribe to the channel. Gene also has a Patreon, which you can support his work, the TriMag work, which we're going to talk about. And all this came from poleshiftnews.com, which is MavStar Obsrevatory and Gene Beard's pet project. And it is, in fact, what we're going to be discussing today, the TriMag data. Now, Gene, could you just give us an update on how many of these new units are out there, the data that's coming in, and what we now know?
Okay, so recently we set up, we just proposed the idea back in January, late January, February. We said it would be a great idea if we could get some magnetometers at different locations around the world, ideally to latch onto those 4 magnetic poles that we have around the planet at the moment. Some people think we've got 2 magnetic poles, one on the north and one on the south. In fact, we've got 4. We've got 2 over the northern hemisphere, 2 over the southern hemisphere. And what we've done is we have designed these magnetometers specifically to measure the background magnetic intensity in these regions. And we have managed, as promised, to send these magnetometers out to pretty much cover the 3 major highest intensity regions, or those 3 main poles. That first one being in Siberia, where we've got 2 magnetometers right now in the United States, one in Southern California, one in Kentucky. That monitors we've put them just on the fringe of not the highest intensity over the Canadian pole, but just on the fringe where it goes into the highest intensity. That's because we know that the Canadian pole is reducing rapidly and has done probably 50% of its entire strength over the last 7 years. It's reduced by. Then over the Siberian side of the poles, over the northern hemisphere, we've got now a magnetometer in Hong Kong, and this week we should have come online one in India, and that will be tracking, again, not the highest intensity, because what we want is as these poles move about, we want them to be in the vicinity of where our magnetometers are, and we've really chose some sweet spots for these magnetometers. I think even NASA would be proud of what we've managed to achieve on the observatory with, the little budget that we've had. And what we're trying to do is just catch the increase in intensity as it moves from the Siberian pole down to the equatorial region. And as it does that, it's going to bypass our magnetometers. So what we're going to be seeing from the Siberian pole, or those 2 magnetometers, one in Hong Kong, one in India, we're going to see the intensity increasing, hopefully, over the next 6 months. I did say to my subscribers that, we're going to wait at least 3 months before we start making any speculations at all on the data that we're collecting. Right now, we're very just much coming out of the test phase. We've managed to get these magnetometers to the location, get some test data back to us, which we've put up on the Poleshift News website, which is the home of the MavStar Observatory. And, we've also got 2 down in Australia. We've got one on the west coast, right on the west coast, and right on the east coast. One in Perth, one on the Gold Coast. However, we've had some technical problems with the one in the Gold Coast. That should be back with me this week, and hopefully, if it's not too serious, we should be able to get that back up and running and sent straight back out to Richard over there, who's housing that. So we've got some great people. We've got JD in Southern California. We've got Brad in Kentucky. We have Tony, who's a female pilot in Hong Kong. Ricky in India. We have Richard on the Gold Coast, and we have Jeff in Perth on the East Coast. So we've got some sweet locations for these magnetometers. And on top of that, we've got the Trimag system here in the UK, as well as a magnetosphere sensor as well. So we've got a lot of data now coming in. The workload has increased 6-7-fold. And, it's a bespoke observatory, which is dedicated to providing information on the biggest anomaly that is taking place that is hardly heard of. Probably less than 2% of the entire world's souls or population know about the migrating poles. And like you say, it could well be an excursion, but being 500,000 years overdue, a full magnetic reversal, it's a hard one to call. But nevertheless, if it is an excursion, as you know, David, they last 12,000 to 14,000 years, and at some point in between that period, we're going to hit a period where the magnetosphere collapses pretty much down to 10-15%, maybe even less. And it's during that period of time that people are going to be at risk, as well as all the other biodiversity. And quite easily, it could be something like that sent the prehistoric animals into extinction, because we've now found, as you rightly pointed out, that through magnetic reversals, we have a lot more cosmic radiation in. On top of this as well, we also are in a period of low solar output, which is classified, or more commonly spoken, as the grand solar minimum. And, we couldn't be facing a worse case scenario, because first of all, when we have a low solar output, we get a weakened heliosphere, which is the bubble that protects our solar system. And that lets more cosmic radiation in from our galaxy and other galaxies throughout the universe. This stuff comes streaming in. And on top of that, our second line of defense, and more importantly, the most primary defense, which is our magnetosphere, is starting to weaken and during this magnetic reversal. So we of this magnetic reversal. First of all, we're getting more cosmic radiation inbound in our planet, which is setting up seeding effects in our atmosphere, where more cloud nuclei develops and obviously turns into clouds, and then ends up in our jet streams. And the jet streams start to get wider, start to get more sluggish, and they start to break down. And we can see this now happening even on good sites like North School. We can see it where they actually dislocate from the polar jet streams and end up in the subtropical jet streams. And of course, what we're getting is clashes between the humidities. You're getting a lot of moist come off the subtropical region, go up into the polar jet streams, and then drop in snow. And then you're getting the opposite effect. At the troughs of the jet streams, we're getting these cold winds come down, meet the warm air, and of course we're getting these flash floods that we're seeing, that has devastated humongous crops in America. I believe 10% has been wiped out. Is that correct, Dave?
Well, the USDA and a lot of the sources we've uncovered in the last 3 days have actually been hiding information, and the information that we've been getting is not correct. But before we go any further, Gene, we were talking about the fact that we're overdue for a magnetic reversal, and you were talking about the duration of these excursions. There is recent scientific data and papers to even suggest that as in the last two excursions, which would be like the Mungo and the Landchamp, that there were time period within 300 years the entire excursion had happened or less. In some instances, during the Mungo Lake data, which is lava flows, the actual poles are flipping back and forth near the equator in a matter of months, back and forth. And this is during the collapse period, which you said the magnetosphere wanes to around 10%. This would be an extinction level event. And if we were headed there, well, God bless us all. But let's get to the effects of the weather. We're looking at null school here. And on our channel, we tell everyone that during these solar minimums, you go from a zonal flow to a meridional flow. And during grand minimas, the jet stream becomes very chaotic, which we're seeing right here. Do you want to talk more about that?
Yeah, if you could just show your viewers, a good look over the northern hemisphere right now. And then if we can just compare that, if we can get directly over the northern hemisphere on that, okay, that's perfect. And then if you just take a look at what the condition of our jet streams are now, we're looking at the subtropical and polar jet streams, but they're almost indistinguishable. And this has been the case now. Which is nice, wavy, and then again at 30 degrees we should have the subtropical, but you can see that there is a lot of interchange between the two, and that's what really is causing a lot of the problems that we're seeing right now across the northern hemisphere. If we can just flick that over, Dave, and have a look at the southern hemisphere, I want to point out something a little bit different. Okay, so we can see straight away that there is something more extreme going on. And this just so happens to be the region where the ozone hole is on our planet. And it's baffling scientists now as opposed to why it is shrinking as opposed to getting bigger during the temperature that we're receiving right now on the planet. And I propose that this is because we have a lot more inbound cosmic radiation. And, recent scientific studies have shown that when you get a lot of cosmic radiation into an area where there's aerosols, that it actually attaches to the aerosol, becomes a bigger particle, and that in turn then encourages water vapor to condense on that particle. So we've got cosmic radiation attaching to aerosol particles. They're forming bigger particles and therefore becoming big enough to have water condense on them. And I believe that is why right now we are seeing, first of all, a shrinkage of the ozone because those particles are mixing with cosmic radiation, which is inbound because of twofold reasons. First of all, the grand solar minimum. Second of all, a weakened magnetosphere, probably around about 20% right now. And as a result, you can see that there is more precipitation in the jet streams, and in some cases, just look at them, we've got probably 2,000 mile wide jet streams. And again, like in the northern hemisphere, there is no separation from subtropical to polar jet streams. And this again is what is causing major problems around on our planet, and not just cropping, but when we get more cosmic radiation in, scientific surveys and studies have shown that, it even affects not even is it possible to cause, cancers in biodiversities across the range, not just humans, but vegetation as well. But it also can cause now, as it has recently been found, cardiac arrhythmic problems, even in healthy people. So we got a lot more of this to come. We're nowhere even close to reaching equilibrium because we haven't even started to begin to see, the poles moving to those weaker field lines where they migrate a lot faster. So, this is just really starting to get going. My real concern is that when we do go into the weak field lines, what we've seen gradually take place what we're looking at now with jet streams could be, a hell of a lot worse. And it's no wonder the bigger organisations aren't coming out and talking about this. And that's why we dedicate ourselves on the Pole Shift News and at the MavStar Observatory to informing the general public. And we're not doing a great job at it, really, because we know we're not just reaching enough people. More people need to know what is going on scientifically with their planet.
Well, we have to start somewhere, Gene, and let's start by explaining what's going on with the polls and the data coming in. You can't make any conclusions for 3 more months, but what we're seeing currently is with the TriMag data that you have already gleaned in the UK over there. What can we glean from the new data early? We know that there has been an acceleration.
Okay.
We know that the world magnetic model has changed. What are we waiting to see?
Okay, so it's been really exciting times. I know that it's not probably exciting for some people that are on the other end of the spectrum of this, but for me, to have the TriMag system up and running for a good 2 years now, for the last 3 months, what we've seen is some really exciting activity. We've seen the poles move probably 250 miles east and then back west, going towards Siberia, and it's becoming more frequent. We're seeing this activity a lot more. Just around Christmas time, we came out and announced there was an uptick in the behaviour of the magnetic poles. And, a month or so after that, well, around about a month after, say 6 weeks after, NASA came out and released the same data. So we beat them to the table, really, with that respect. And I think that is just down to the resolution that we record. It's every 3 seconds, 24 hours a day, 365 days a year with the TriMag. Some people were saying that it's way too much resolution, but it just shows when you are looking at things in 3-second intervals, you're not missing much what's going on with the magnetic North Pole. And what we started to see was some what I described as magnetic jet movement, where we was just getting a little spike every 3 seconds, but it was enough to show up on the data. What we're getting now is something even more alarming. We're starting to see some really big spikes and some movement in the magnetic North Pole, where it's yondering, backwards and forwards, 250 miles. So, it's really exciting times right now. We're starting to see, some real magnetic pole migration. Even though it is still 250 miles, we are getting closer, ever more so to that 40-degree mark. And, as I've explained many times, 40 degrees, you'll find that it starts to move around a lot lazier. And what that is an indication is that it's now coming out of the strong field lines, which hold poles in their position permanently, and it enters the weak field lines after that point. And when it enters the weak field lines, they generally move a lot faster. So I predict probably within 5 to 7 years, we're going to start to see, if not even earlier with the recent activity that we've picked up with the TriMag, we could see a pole shift come well within a decade. And, along with that, we're going to see all the problems that come with it. If anything to go by over the last 30 years of what we've seen, how the poles migrating have affected, the global climate, then what we're going to see when they enter the weak field lines could be an exponential increase in that activity. It's all new and it's all up for speculation.
With the TriMag data, we'll actually be able to know when there's a rapid shift. With the powers that be in the world magnetic model, they're only updating that every 5 years. So we have the edge.
Yeah. Oh, definitely, yeah. I mean, like I say, just before Christmas, we came out and made an announcement before even NASA did that there was some activity that was showing up abnormally with the poles. And we came out well before NASA. We did it twice. before NASA did. So, just goes to show that what we've built is doing its job and doing it very well. I knew I was hesitant when I selected the resolution of every 3 seconds, whether that was a bit much, but it absolutely done a fantastic job over the Christmas period. We detected those magnetic jets, and since then we've detected a lot more regular and larger activity. So things are definitely warming up over the northern hemisphere right now with the magnetic North Pole.
Well, Gene, it's been a pleasure, and we're really looking forward to the first analysis of the new TriMag data, which will be coming out in a month or so. If you don't know about Maverickstar Reloaded, he has a Patreon page. Come support him over on his Patreon. There is a YouTube channel where you can get daily updates, and go check his work through the years. You can go watch all of the older videos. They're all up there. It's been a pleasure, as usual, Gene, and I hope to do this soon again. Probably once you do the first analysis of your TriMag data. We'll all be looking forward to that. And you'll keep the listeners updated if there's any rapid shifts in the pole. I'll be the first to know, right?
Absolutely, Dave. In fact, we are considering doing probably, what usually happens, we collect the data or we process the data on the 17th or thereabouts of every month. We're thinking about reducing it down to probably 2 weeks. But I'll definitely keep you informed with regards to any new activity. Don't worry about it. I'll have you on the hot phone.
It's been a pleasure. Ladies and gentlemen, Gene Beards, MavStar Observatory, poleshiftnews.com. Be safe. We love you. Thanks, Gene.
You're welcome. And thanks.